Okay, a textile dye manufacturer create a yellow dye. Diagram 40 shows the percentage composition of the dye. So this is a percentage given. What is the molecular formula of the dye? Okay, to find the molecular formula. So to find the molecular formula, you need the formula. Okay, this one. Okay, this formula is very important. Molecular formula is equal to empirical formula times n. N is a value of unknown. So to get the molecular formula, first, you must have empirical formula. Second, you must have the value n. So what does that mean? For example, glucose. Okay, glucose. Now, what is the molecular formula of glucose? C6H12O6, right? And then what is the empirical formula of the glucose? Empirical formula is the simplest ratio of the atom of the element. So 6 to 12 to 6. When you simplify it, 1 to 2 to 1. So empirical formula is CH2O. Okay, C1H2O1. CH2O. So this is the empirical formula. Okay. Now, so when you have the empirical formula, okay, when you have the empirical formula, can you get the molecular formula? Yes. Empirical formula, if you times 6, you will get back the molecular formula. Okay. So to get the molecular formula, you must have the empirical formula and you must have the n unknown. Okay. So this is the two important information you must get first. Okay. Now n is unknown. It's a value. It is a value. So to get this value, you must have the number. So how we can get this number? We get it from the relative molecular mass, RMM, relative molecular mass. The value for relative molecular mass is same as the molar mass. The difference is relative molecular mass has no unit. Molar mass, it has a unit. So relative molecular mass of the molecular formula is equal to the relative molecular mass of the empirical formula times m. You just modify this formula to the relative molecular mass. Okay, now first thing, okay, so first thing we must find the empirical formula. So now first we must find the empirical formula to get the molecular formula. To find the empirical formula, okay, we must know the element. Okay, we have carbon, okay, we have nitrogen. Okay, we write hydrogen first. Okay, hydrogen. Why I write hydrogen first? Because in the answer, hydrogen comes first. Okay, and then we have nitrogen. Okay, now carbon, it has 75.95% from the equations. Hydrogen, it has 6.33%. Okay, nitrogen, it has 17.72%. 72%. Now, to find the empirical formula, you must get the mass, because from the mass you can get the number of mole. So how can we change the percentage to the mass? So we make an assumption. We assume that the mass is 100 grams. Why we use 100 grams? Because the percentage of percentage is 100%. So we use 100 grams. Okay, to change it so that easier. You can use 50 grams also can, but you need to calculate. Okay, so we use 100 grams. So we assume that mass in 100 grams. So 75.95. 75.95% in 100 grams means you have 75.95 grams. 6.33% in 100 grams means you have 6.33 grams. 17.72% in 100 grams means you have 17.72 grams. Okay. That's why we make the assumption in 100 grams so that we can do the calculations. So third one, you must find the number of mole. Okay, remember our final destination here to find the empirical formula. So number of moles. Number of moles is equal to mass divided by molar mass. So mass is 75.95. Molar mass for carbon, okay, in the question is given, carbon is 12. Carbon is 12. Then you get the number of mole is the 6.33. 6.33 moles. Okay, so hydrogen also same. Number of mole is mass divided by molar mass. Okay, mass is 6.33. Molar mass of hydrogen in the equation given is 1. okay, divided by 1, you also get 6.33. Nitrogen also same, you want to find the number of mole is equal to mass divided by molar mass. So mass for nitrogen is 17.72. Molar mass for nitrogen in the question given is 14. Okay, 14. So the number of mole you get is 1.27. Okay, now you get the ratio of mole. Ratio of mole is you find which one, okay, between carbon, hydrogen, and nitrogen, which one is smallest number, you divide it by the smallest number. So this carbon is 6.33 moles, hydrogen 6.33 moles, nitrogen is 1.27 mole. So to get the ratio of mole, you divide it by the smallest. Why divided by smallest? Because we try to get the whole number. If you divide it by the big number, you might get the decimal place. So that's why we find the smallest number so that we can try to get the whole number. So 6.33 divided by 1.27, you get roughly 5. Okay, 6.33 divided by 1.27, you get 5. 1.27 divided by 1.27, you get 1. So the simplest ratio is 5 to 5 to 1. This one is simplest already. You cannot simplify anymore. That's why the empirical formula you get carbon is 5, C5. Hydrogen also 5, H5. Nitrogen 1, N. Okay, 1 no need to write. So this is the empirical formula. First step already. Now second step, we need to find N. Okay, to find N, we need to use this formula. Okay, relative molecular mass. So we use this one. Okay, so relative molecular mass of the molecular formula. Now this one normally is given. Okay, you look from the question. Molar mass of the dye. Dye is a molecule here. Okay, it's 237 gram per mole. So 237. Okay, is equal to relative molecular mass of empirical formula. This is the empirical formula. So you need to find the relative molecular mass. You have 5 carbon, 5 carbon. So 5 times molar mass or relative atomic mass for carbon. Relative atomic mass for carbon is 12, given here. 12. So 5 times 12 plus hydrogen, you got 5 also. Hydrogen, you have 5 here. 5. So hydrogen relative atomic mass is 1. Okay, 1. So 5 times 1 plus nitrogen. Nitrogen you have 1. Okay, times relative atomic mass for nitrogen is 14. So times 14. Okay, N. Okay, we're trying to find the value N here. So your N will be equal to 3. 3, you use calculator, you get N is equal to 3. Now you have the value of N already. N is equal to 3. So now you can find the molecular formula. Molecular formula is equal to empirical formula times N. Your empirical formula is C5H5N. Okay, times your N is 3. So it's equal to C, 3 times 5 is 15. N also 15. H15, H is 15. Okay, H15, and you got 3. So the answer is D. Okay, answer is D.